Hello everyone. So we are came here again with this new topic which is the Coulomb's law. Let us see what is the Coulomb's law. So in the electrostatics we saw some electrostatic forces. So what kind of force we have studies? So forces are classified as basically two types. First one is a contact force and the next one will be the non-contact force. Like in the list of a contact force, we have a frictional force, we have a normal reactions and tensional forces. In the series of a non-contact force, we know about the gravitational force, the magnetic force, electrostatic force also the part of that. Okay, so if I'm just talking about the electrostatic force, so we have a basically two different kind of a charges. One is a positive, another one is a negative. So as we know from the earlier knowledge that they both becomes attract each other. So what we can say that electrostatic forces is a non-contact forces because at a particular distance they will start to attract and they will start to repel each other. French scientist named as Charles Augustin de Coulomb gave the law on these non-contact forces, which is called as Coulomb's law of forces. So what is the Coulomb's law of forces? Are you students excited for knowing this particular thing? So it states that the force of attraction or repulsion between two-point electric charges at rest is directly proportional to the product of a magnitude of the charges and inversely proportional to the square of a distance between them and act along the line joining of a two charges. So during the board examination, most of the students are writing only this much thing that the charges are directly proportional to the product of magnitude of the charges and inversely proportional to the square of a distance between them. But what things you have to mention, which is a more important, that is a direction, which is along the line joining of a two charges. Okay, the distance between them and act along the line joining between the two charges. Okay, so we have a two charges, distance r, so f is directly proportional to the q1, q2 and inversely proportional to the square of a distance between them. So we can say f is directly proportional to the q1, q2 by r square. If this proportionality sign will be removed, a constant will be k in the nature, which is a k. The value of a k is 1 by 4 pi epsilon naught. Earlier we saw the value of epsilon naught, which is 8.85 10 to the power minus 12. We can calculate the unit of this, which will become Coulomb square per Newton meter square. So 1 by 4 pi epsilon naught q1 q2 by r square, this is the value of f. Here epsilon naught is the permittivity of air or free space and we get the formula and the value by this equation. Clear? So value, as I told you earlier, 8.85 10 to the power minus 12. Unit of epsilon naught we can calculate, that is a Coulomb square per Newton meter square. Clear? The value of a 1 by 4 pi epsilon naught is a 9 10 to the power 9 Newton meter square per Coulomb square. So we know that force requires some magnitude as well as direction. Reason is why. Answer is here, that is a force is a vector quantity. That's why it needs both magnitude as well as direction. Hope I'm clear. So force is a vector quantity and a vector form of a Coulomb's law of force is a what? That is a, if two charges q1 and q2 are located at a particular distance, that is a r, so because of a q1, they will apply some force, like q2 apply some force towards q1, so that is a f12, and f12, that is a f1 applied on the force f2. Okay, so f basically 2 applied by on the 1. This will be 1 by 4 pi epsilon naught q1 q2 by r square. Okay, so there will be unit vector also present, because if we just write down the direction, so as we know, force is a vector quantity, so exact represented will be like that. 1 by 4 pi epsilon naught q1 q2 by r square r cap. What is the r cap? This is a unit vector, which is just the showing the direction actually of the force. So we know the value of r cap also. R cap gives the value of a vector r upon mod of r. Mod of r gives only the magnitude. So we can write up as a r. If we put this value over there, so this will be vector r12 into r. We give this value of r here. So r square into r, this will be converted itself into the r cube. Hope I am clear. Similarly with the F21, so F21 gives the value 1 by 4 pi epsilon naught Q1 Q2 by R cube with this direction R12. Clear? Now, this both direction will showing in the form of a displacement. Now, R12 is equals to minus R21. Because as you can see the directions, they both have the same direction, but the distances are equal. Magnitude are equal. That's why we are saying that direction is the opposite, but distance, that is the magnitude, is same. So directly we can say that F21 is a 1 by 4 pi epsilon naught Q1 Q2 by R square is a negative of F21. F21 is equals to minus of a 1 by 4 pi epsilon naught Q1 Q2 by R21. That's why we can say that F12 is equals to minus of F12. Clear? F21 is equals to minus of F12. So magnitude of a force we can also find out, that is F21 is equals to F12, which is equals to 1 by 4 pi epsilon naught Q1 Q2 by R square. So let's move with this MCQ question so that we can understand how much we just get from the knowledge. Coulomb's force is true for only dash charges: moving, static, both A and B, none of these. So the correct answer for this question is static charges. We are studying this topic like Coulomb's force in the electrostatics. Static means the charges when the charges are in the rest position. So this is the part of electrostatics. We can say directly the static form of a charges is the part of a Coulomb force. Moving ahead with the next question, the force of attraction or repulsion between two stationary point charges is dash to the product of their charges and inversely proportional to the square of a distance between them. The A inversely proportional, B equal, C directly proportional, D is greater than. So the correct answer for this question is C, directly proportional to the product of their charges. Moving ahead with the third question, the condition that should satisfied for the Coulomb's law is A, it is only true for the static charge. B, it acts along the line joining of two charges considered to be point charge. C, it is true for a moving charge. D, both A and B. So the correct answer for this question is option D. That means it's true for the static charge as we see earlier. And it will be applicable for the point charges also. So according to that, the A and B option will be, that means D option will be the correct answer. Charge distribution. So charge distribution we can do in the different manner, like a uniform charge distribution where the charges are uniformly distributed over the particular sheets, like this. So when the charges is not accumulated in some part but separate uniformly, we are saying this charge distribution will be uniform. Second, non-uniform. As you can see, there will be a particular space where the charge accumulate in the clouded way. Okay, like this reason. So more charges is accumulated at the curved and the sharp points. So this will be non-uniform. Charge density is a what? It is a quantity which representative or representate the charge distribution. Like the density is equals to mass per unit volume. So mass represents basically in a volume. This is a uniformly charged distribution. So charge density will be charge divided by volume. The charge present in the volume. So the charge density will be types of a charge density. We have basically three types of charge density. Linear charge density, surface charge density, or we saying this one also as an areal charge density. Areal charge density. In some book you will be get like this. Volume charge density. Okay. So one by one we will see all the parts. Like the first one is a linear charge density, which is represented by the term lambda. Okay. Now, charge per unit length is defined by this term like a linear charge density. So, lambda is equals to Q by L. For a rod, okay, L will be the length, Q will be the charge, which is a uniformly distributed. So, the lambda will be Q by L. So, this will be for the circular ring. Like if we just take in a circular ring of the radius R, the charge Q, so lambda will be Q by 2 pi r. Because why we are taking? Because the length of the wire or the ring will be 2 pi r. So that's why for the ring this will be Q by 2 pi r. Lambda is equals to charge on a small element divided by length of the element here. So lambda is equals to dq by dl. Unit if I'm just taking, so Coulomb per meter. Dimension L minus 1, M0, T1, I1. Moving ahead, like there will be another one which is surface charge density, which is represented by the term sigma. So charge per unit area is defined as a surface charge density. That means a surface has only area, which is represented by the sigma is equals to Q by A. For a disk, if I'm just taking uniformly charged distribution, so radius will be R, charge is a Q, so sigma will be Q by, disk area will be pi r square, so A will be Q by pi r square. Sigma is equals to charge on a small element divided by the area of the element. So sigma is equals to d Q by dA. Unit for that Coulomb per meter square, and the dimensions for that L minus 2 M0 I1 T1. Volume charge density, which is represented by the rho, which is charge per unit length, as we saw in the first one. The charge per unit area we saw in the surface charge density, and charge per unit volume is a volume charge density represented as a rho. So a sphere has a volume, that is a rho is equals to Q by V. Now for a sphere, if I'm just taking a sphere, for the uniform charge distribution, the radius will be R, charge will be Q. So rho will be Q divided by, and the volume for this is 4 by 3 pi r cube. So rho is equals to Q by 4 by 3 pi r cube. And rho gives what? Charge on a small element divided by the volume of the element. That means rho is equals to dq by dv. Units for Coulomb per meter cube, and dimensions for that L minus 3 M0 I1 T1. Charge density we can calculate like this. Like example if I'm taking, so for rod, relation lambda by QL, unit Coulomb per meter, dimension L minus 1 M0 T1 I1. Formula lambda is equals to Q by L. General formula lambda is equals to dq by dl. For surface charge density, which is sigma, for disk, sigma is equals to Q by A. Coulomb per meter square its unit. L minus 2 M0 T1 I1 its dimension. Formula sigma is equals to Q by pi r square, and general formula dq by dA. For volume, we are just taking a sphere. And for sphere, rho is equals to Q by V, because surface have 3D diagram. This will be containing volume. So the unit for this is a Coulomb per meter cube, L minus 3 M0 T1 I1, and rho is equals to Q by 4 by 3 pi r cube, rho is equals to dq by dV. Let's move with this question so that we can understand what actually we understood from the first topic and from the second. Surface charge density is denoted by lambda, rho, E or sigma. The correct answer for this question is a D, which is sigma. Second, the unit of linear charge density is A Coulomb per meter, B Coulomb per meter square, C Coulomb per meter cube, D Coulomb per meter 4. So the correct answer for this question is a Coulomb per meter, which is the A option. Moving ahead with the next question, the dimensions of the volume charge densities are L minus 1 M0 T1 I1, L minus 1 M0 T1 I2, L minus 2 M0 T1 I1 or L minus 3 M0 T1 I1. So the correct answer for this question is option D. Force between multiple charges. So if I'm just taking the mutual electric force between two charges, so we can calculate this by Coulomb's law. So how to calculate the force of the charge? Where the charge are not one but several charges around there. So consider we have this number of a charge which is in the stationary like Q1, Q2, Q3 up to Qn, which is in the vacuum. So what is the force on it? Q1 due to Q2, Q3 and up to Qn. So Coulomb's law is not enough to answer for this question. Recall the force of a mechanical origin which add according to the parallelogram law. So experimentally we found that forces of any charge due to the number of other charge is a vector sum of all the forces. Like we have a different kind of forces, so we can, if we want to calculate the net forces, we just add up all these forces. Clear? So the individual forces are unaffected due to the presence of other charge. This term is called as a principle of superposition. This point is the most important for the board exam also, that individual forces unaffected due to the presence of other charge. This term is defined as a principle of a superposition. Principle of a superposition does not define the summation of other charges only, defines that individual charge unaffected due to the presence of a charge. This is the right statement. So we have a number of charges. We can calculate the resultant force from here also, as you can see. So Q2 apply for the force on the Q1, which is a F12. Q3 applied force Q1, which is a F13. So the resultant force we receive, this will be the F. Consider a system of 3 charges which containing Q1, Q2 and Q3 only charges. So the net force we can say Q1 due to the other 2 charges. By performing the vector addition of the forces, this will be like this. So thus, if the force will be Q1 due to Q2, so it is noted by the F12. And F12 is a given even through other charges at present. Thus, F12 is equals to 1 by 4 pi epsilon naught Q1 Q2 divided by R12 square R cap 12. In the same way, the force on a Q1 Q2 or Q1 Q3 denoted as a F13 or F12. That means F13 is equals to 1 by 4 pi epsilon naught Q1 Q2 by R square 13 R13 cap, which is again the Coulomb's force Q1 due to the Q2. Even through the other charge is also Q2 present. Okay. So thus the force of F1 on the Q1 of the 2 charges Q1 and Q3 is given by F1 is equals to F12. This is the first force, and next F13. They both will accumulate and give the resultant, which is a 1 by 4 pi epsilon naught Q1 Q2 by R1 square. Okay, R12 square, R1 cap, R12 cap, plus there will be no equal sign there. This will be only plus 1 by 4 pi epsilon naught Q1 Q3 divided by R13 square R13 cap. The above calculation force can be generalized into the system of a charges more than 3. Okay, like we had just taken earlier example for the 3 charges, but it is not compulsory only for the 3 charges. It may be n charges. Okay, so the principle of superposition says that system of a Q1 Q2 up to Qn, the force on Q1 due to Q2 is same by the Coulomb's law. It is unaffected by the presence of a Q3 or a Q4 or a Qn. So the net force F1 for the Q1 due to other forces will be the like this. The summation of all, that F12 plus F13 plus F14 up to F1n. 1 by 4 pi epsilon naught, which is a common in all the factor. So inside term will be like a Q1 Q2 divided by R12 cap plus Q1 Q2 divided by R13 square R13 cap up to Q1 Qn divided by R1n square R1n. So we can use here like the sigma. See, we have two values. I just want to elaborate more firstly here. Summation, this will be also signified. And sigma also defines the form of summation. So what is the difference between these two? This is a discrete summation and this is a continuous summation. So in the vector sum, we obtain usually parallelogram law for the addition of vector all the electrostatics in the basically a consequence of a Coulomb's law and the superposition principle. Let's move with some questions for more clearance. A charge Q1 exerts some forces on a second charge Q2. If the third charge Q3 is brought near, the forces exerted by the Q1 Q2 will be decrease, increase, remains unchanged, increase if Q3 is same sign as a Q1 and decrease if Q3 is opposite sign. So what was the correct answer for that? Just quickly given the quick answer. Yes, the correct answer will be the C, remains unchanged. That means Q1 applies the force on a Q3, Q2. So there will be no change for the Q3 term. If Q1 applied force for the Q3, there will be no change for the Q2 terms. Moving ahead with the next question, two charges are placed at a distance apart. If the glass slab is introduced between them, then the mutual force between the charges will be increase, decrease, remain same and become zero. So the correct answer for this question will be decrease. How this will be decreased? I just want to elaborate here. So the formula of force is equals to 1 by 4 pi epsilon naught. This is for the free space. If I just include a medium, so the medium constant also present over there, which is a K. Q1 Q2 by R squared. So if the medium constant is present, as you can see here, so if the value of a K increase or change, force will be. So this is all for today. Thank you for the session. I hope you earn more and more knowledge from the session. Thank you for watching this video. Take care everyone.